Hello everyone, and welcome to numerical problem of network theory. And today our numerical problem is, in the given network K is closed at t equal to 0 with 0 current in the inductor. Find the value of I di by dt d square I upon dt square at t equal to 0 plus if R equal to 8 ohm and L equal to 0.2 Henry. And this is the circuit diagram. Solution is, if switch K is closed at t equal to 0, then I0 plus equal to I0 minus equal to 0. The value of current is 0. Then the switch is closed. Then applying in this circuit, apply KVL. Then we get, this is the KVL equation, Ri plus LDI upon dt equal to 12. This is the value of V. So value of R is 8 and value of L is 2. At t equal to 0, that is 8 I0 plus 0.2 di 0 plus upon dt equal to 12. And we know I 0 plus equal to 0 from here. Then put the value of I 0 plus. This is 0 plus 0.2 di 0 plus upon dt equal to 12. So this value is 0. Then solving this value, we can get the value of di 0 upon dt equal to 12 by 0.2, that is 16 ampere per second. And again we have to differentiate this equation 1, and differentiating equation 1 we can get 8 di upon dt plus 0.2 di square 0 di square upon dt square equal to 0. This is the value of V, so we differentiate and the constant is 0. 8 t equal to 0 plus, that is 8 di 0 plus upon dt plus 0.2 d square I0 upon dt square equal to 0. So this value we have already find 60, therefore 8 into 60 plus 0.2 d square I0 plus dt square equal to 0. We have to find the value of d square I0 upon dt square. So by simplifying this, we can get 0.2 d square I0 upon dt square equal to minus 480. This value is 480. Then simplify this, we can get d square I0 upon dt square equal to minus 2400 ampere per second square.